Hey you guys, we've made it through another week of Chemistry 110, just a few weeks left. I wanted to start off with talking about one of our discussion questions actually that references this image here. So hopefully you got the reference. This is, related to Lord of the Rings. We have our Gollum type character, which is our oxygen atom, and it's violent, not wanting to share my precious attitude of the electron that it otherwise is sharing with the hydrogen atom. And so this actually gets into quite a few things from our week. So I'm going to do a little bit of drawing here. Any second now. Come on, there we go. Okay, so we have our, our oxygen atom. This is the Lewis structure, the structural formula for water. 2 single bonds. And we were learning this week about electronegativity and the electronegativity difference. So electronegativity is a measure of how strong atoms pull on their shared electrons. So we know here this line represents 2 electrons. And oxygen and hydrogen are engaged in a little bit of a tug of war over those. So they're pulling them back and forth. And electronegativity measures how strong that particular atom is in that tug of war. And I wouldn't expect you to know this off the top of your head, but if you look up the electronegativity for oxygen, for example, in the chart that's in your textbook, you'll see that its electronegativity value, I'll put it over here, is 3.0, and hydrogen's is 2.1. So oxygen pulls on shared electrons a lot stronger than hydrogen does. So it's like this creepy looking oxygen atom here going, my precious. And because of that, because it doesn't win in the tug of war, like yank the electrons away to make ions, but the electrons do end up spending more time on what we would say is the oxygen side of the water molecule. So they're over here, even though they might belong to the hydrogen, they're actually over here more often. And that inequality in electron density does result in partial charges. And we say partial because water is not ionic. The oxygen is not negative, it's a little bit negative. And the hydrogens, because they don't have their electron there most of the time to cancel out their one little proton, our hydrogens are a little bit positive. And we express those dipoles using the symbols, those little delta symbols. So water then is a polar molecule. In fact, not only is water polar, water is like hella polar. It's especially polar. And one of the things that you probably learned about this week, and we're going to continue into the next week, is that polarity of water, this unequal distribution of electrons, making the water molecule a little bit charged, explains a lot of its unique and unusual properties. So if I have my little models here of water, if every single one of them has these opposite poles, partial negative, partial positive, then they're all going to be attracted to each other. Opposites attract, so oxygen to hydrogen. And if you think of even just a few teaspoons of water has 602 sextillion water molecules, and every single one of them is weakly attracted to each other, that's going to influence a lot of properties of it. That's going to make it difficult, for example, to get them to vaporize. And we're going to continue to explore that in our upcoming week. So, highlights from this week. Overall, our week kind of followed its, normal pattern. We had discussions, we had videos. I have enjoyed having a few more of you stop by my office hours and getting to know more of you and getting to help more. Quite a few more people starting to really look at those practice worksheets, which is great. I think, honestly, our biggest highlight is just our continued resilience and survival in the face of a global pandemic. The patience that we continue to show to the people around us, even those who might disagree. But the highlight for my week has been the competition for best lab selfie that I talked about last week and how you can potentially get some extra credit this week. I've actually decided to give 1 extra credit point to everybody who participates at all, and then an additional extra credit to the person whose lab selfie is, in my opinion, on my estimation, the best. So there's some of our highlights. Our learning outcomes, you can see there on the list, we've covered things like electronegativity, unique properties of water, which we're actually going to continue to explore next week. So in your discussion, you got to talk about, like, why do we look for water when we're looking for life in other places, and what, do you think we'll find life? Obviously, that's really an opinion question, but the reason we look for water is because life as we know it on Earth could not exist without water, and definitely did not exist prior to water being here in the quantities and way in which it is now. And so some fun things about water is water has a really high boiling point. Considering what a tiny molecule it is, most molecules that size are vapors or gases at room temperature. But water stays in the liquid form. Why? It goes back to what we were just talking about, and its polarity. What that means, what that allows for, is water to be in the liquid phase at most, normal temperatures on Earth. And that's important for life because for chemical reactions of living systems to happen, we need those particles to be dissolved in a liquid. They need to be able to have motion as opposed to being in a solid, but they also need to be able to come in contact, and gases are too far apart. So that's just one of the many reasons that water makes life on Earth possible. And you read about more, and again, we're going to explore more in the future. And nearly all, if not all, of those unique properties of water come down to these objectives here on what we call hydrogen bonding. Now, hydrogen bonding isn't really bonding at all in the traditional sense. It's not inside a molecule, like a covalent bond and ionic bond. Those are the names for the forces that keep the compound together, like that one molecule. Hydrogen bonding is a type of what we call an intermolecular force or an intermolecular attraction. So I have two separate molecules and their attraction for each other, as opposed to a covalent bond, the sharing of electrons inside. And you know that hydrogen bonds are quite a bit weaker, only about 5% the strength of a covalent bond, but super important, especially when you have large quantities of molecules that are engaged in hydrogen bonding. That net effect of all of those adding together can be really significant. Now, not every hydrogen engages in hydrogen bonding. So hopefully, as you learned this week, it's when hydrogen is bound to a particularly electronegative element. Essentially, when the sharing is so unequal. So anytime two different elements covalently bond together, there is some type of, tug of war going back and forth, and somebody wins a little bit more than the other. Now, whether or not we classify it as fully polar depends on how big that difference is. But when hydrogen is bound to a particularly, usually one of the three most electronegative elements on the periodic table, then that polarity is so strong, we give it its own name, hydrogen bonding. And so here I have a different looking structure where I have a hydrogen, my white hydrogen, and then I have it bound to green. So if this green is nitrogen, oxygen, or fluorine, or I usually say if this green is enough, if it's one of those three particularly electronegative elements, this polarity created, because this one is so much stronger at pulling electrons, is so significant that we're going to call it hydrogen bonding. And then this partially positive hydrogen is going to be able to be attracted to, something like our water molecule, which is the negative up here. So we see hydrogen bonding in particular places. Now water, since oxygen that's a hydrogen bound to an oxygen, water does engage in hydrogen bonding, which again goes back to some of those unique properties that we have learned about and we're going to continue to learn about next week. So what is next? So you might be thinking like, hey, you used that meme last week, because that's how closely I know you guys watch these videos. And that is true. And it's not laziness, or at least it's not just laziness, but actually our 2 weeks blend together so well that I think some things this week are going to feel like, didn't we just learn this? They just relate so much. Next week, we're going to be looking at more of those unique properties. We're going to put some more names to some of them, so more of the unique properties of water that make our lives possible. Dissolving, particularly dissolving in water, and then the action of soap. And every single one of those relates back to polarity and what we learned about this week. So there's a lot of overlap between these two. And hopefully this meme makes a little bit more sense now, or if it doesn't, it will make more sense later. Some other big things coming up is our Unit 3 test is going to open next week, because these last two modules, Module 6 and then our upcoming module, that's our Unit 3. So that means we will have two discussions, our traditional module discussion and also our unit test prep discussion. And another thing not necessarily related to this class, but I want to remind you, is registration opens up on Monday for summer and fall quarter. So be aware of that if you want to be taking classes in the summer and the fall. And if you have prior to the beginning of this quarter, or maybe the end of this quarter, if you have less than 30 credits, you do need to meet with your advisor in order to get your registration pin. So I just want to put a plug out to that. So what's next? As always, wrap up anything that you have left. Or if you are late on some assignments, take care of those, communicate with me, ask for extensions, whatever you need to do, wrap it up. Check feedback on all your graded work. If something's marked wrong erroneously, let me know so I can fix it. Or if you're not sure why something is wrong, let me know so we can talk about it. Make your initial post to the next week's discussion, preferably earlier than later. And then there are going to be some extra credit opportunities this upcoming week. First of all, there's always an extra credit opportunity whenever there's a Unit 3 test prep discussion board. That opportunity is described in the discussion board, so I'm not going to go over it right now because you can click on that and see yourself. How have you been maybe missing an opportunity for extra credit each time? And then another one is the Easter egg in your learning outcome and to-do list. So if you leave something like maybe in a video game, or in this case, in a document for students that has like something hidden, it's called an Easter egg. So there is an Easter egg, like a literal image of an Easter egg in your learning outcome and to-do list. But if you click on it, it's actually a link. So it's like a hidden thing. And so on the upcoming test, there will be a question, or possibly even questions. This one might have a couple different options for earning more extra credit. I might ask you what it was. I might ask you how it relates to the content, or what was your favorite part of it. So, and because this will be on the test, those points actually, those extra credit points in this context impact your grade a little bit more than just earning an extra credit on a discussion board. So if you have any questions about any of that, let me know. There are quite a few videos this week. So remember, just because they're due on Wednesday, that doesn't mean you got to wait till Wednesday. So you might want to spread those out a little bit over your Monday, Tuesday, and Wednesday to make sure you get through all of them. Hope you guys have a great week. Do something for yourself today, something good for you, even just 5 minutes of silence. I have a little swing outside I like to go and sit in, and it's right beneath this tree, and there's all these birds in there, and I don't know why, but I find it so restorative. So I hope you find something restorative this week, and let me know if you have any questions. See you guys.